Okay, so if we're going to determine whether a molecule is polar, there are really two conditions for a polar molecule, the way that we do it. The conditions are that you have bonds in the molecule that are unevenly arranged and that you have polar bonds. Now, when you go to college and you take organic chemistry, it gets a little more complex than that. But we are doing it in a really, really super simple form, okay? And we just happen to have somebody who's here in college who's taken organic chemistry. And she can verify to you that it's a little more complex than this, okay? She can also verify for you that the system that I've given you for predicting the shape of a molecule isn't so worked out, isn't step-by-step detailed worked out for you the way that I teach you guys to do it. So I've given you a system for predicting the shape of a molecule that's it will be, give you a really good chance of getting the correct shape. It'll get more complex. You'll have these really more complex molecules, and you'll have more than one atom of interest you've got to figure out the shape for, and then figure out how those go together. So it gets more, you build on this stuff. But this is a place to start, okay? So with ammonia, you need to know just from the name what ammonia's formula is, okay? It's one of those few formulas that you just got to know by name: water, ammonia. The others are pretty much named what they appear to be, okay? Like carbon dioxide is carbon and 2 oxygens, but ammonia, you need to know, is NH3. So what I've taught you to do is start with what we call in here Lewis dot formulas for each of the atoms in the formula. So we'll start with a nitrogen and 3 hydrogens in this case. I've already told you in advance what number of hydrogens to use because I told you it's ammonia. Then you're going to go to the periodic table and figure out excuse me, how many electron dots to put around these. So we learned to write orbital notation for that purpose, to figure out how many electrons there are in the outermost primary energy level. That's called the valence level. And so nitrogen has 5 valence electrons. 1, 2, 3, 4. You put one on each of the 4 sides and then pair up on any one of the 4 sides you want to. And then each of the hydrogens just have 1 valence electron. So that's called that's called the electron dot formulas. Okay, each of these are electron dot formulas for each of these atoms. And then we're going to go to what's called a sharing arrangement. So we're going to show how they're going to share electrons. And we want to do this in order to give each of these atoms a full valence level of electrons. Well, a full valence level for nitrogen is 8, but a full valence level for hydrogen is just 2. Most elements want to get to 8, but hydrogen, these really small elements, they just want to have 2. So now hydrogen has 2 and nitrogen has 8 if you include the electrons they're sharing. So that's now a sharing arrangement. From that we can write a Lewis dot formula. We squeeze the electrons in between the element symbols. And that is what we call in here a Lewis dot formula. We don't need a Lewis formula, but while we're here, let's show you the Lewis formula. The Lewis formula simply replaces shared pairs and only shared pairs with lines. It doesn't replace lone pairs. They stay with dots. Okay? Now then, what we want to do is look at this Lewis dot formula. This is the best one for predicting shapes. Okay? We want to count the sets of electrons around the central atom. There are, in this case, 4 sets. Excuse me. A set can be a lone pair, or it can be any number of electrons shared between any 2 atoms. In this case, we've got 3 of those, and we've got 1 lone pair, so we've got 4 sets. What I'm going to call an electron pair shape you get from having 4 sets of electrons around a central atom is a tetrahedral. So this is the way we draw out in a simplified form a tetrahedral, and this shows that I have on the plane of the paper one arm that goes up, one going down here. These are 109.5 degree angles. This one over here with the triangle means that it is tilting up toward you, like I'm tilting this pen up toward you, okay? And you get that kind of an angle there. And the dotted line means it's going back behind the paper, okay? So swinging back away from you. All right, so on each of these arms, then we're going to put the number of electrons that are on each of these sides. So in this case, all 4 sides have a pair of electrons. So this is now this is a tetrahedral geometry, and the name of the type of illustration here, what we're trying to illustrate here, is the electron pair shape. So this is a tetrahedral electron pair shape. The next step then is to take and replace as many sets of these electrons with atom symbols or element symbols as there are shared electrons over here. Okay, so in this case, I've got one set shared with a hydrogen, another set shared with a hydrogen, a third set shared with a hydrogen. So I need to replace 3 of these sets with the symbol for hydrogen. So what I want you to do when you do this is draw out exactly the same shape again. Okay, don't leave anything out in this step-by-step process. When you leave things out, you tend to get things wrong. Okay, and so you're going to have pairs of electrons here, 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 here. Okay, and we're going to replace 3 of those sets. It does not matter with a tetrahedral or with a trigonal planar or with a linear molecule which of these sets you replace. It's a little easier to see if I do it around the bottom, but it's not necessary to only do the bottom. I could replace any one of these 4 sets with a hydrogen. When you get into college and you take your first chemistry class in college, if you're taking chemistry for science majors, you're going to have a lot more complex molecules than we deal with in here. But for the molecules that we deal with in here, you don't have to worry about where you put those atoms. Right now we're just going to be putting on there anywhere we want to. I'm going to put them around the bottom because it's a bit easier to see what you get when you do that. So I'm replacing 3 sets with the symbol for the element those electrons are shared with. And so there's one pair of electrons that's not shared. That's this lone pair up here. Then the next step is to redraw again this exact same drawing. And the reason we do these in pencil is because after we do this and we get to this point, then we want to erase the lone pair. And the reason I have students do this is because when I first started teaching this, I realized very quickly that if we didn't do this step and erase the sets of electrons, the remaining lone pair of electrons, the students would draw this out at as a trigonal planar shape. No matter how many times I said it otherwise, they would just keep doing it. And that's wrong. So I want you to draw out that pair of electrons and then replace it. Okay? If you do it enough times, you'll know. But this way you train yourself to get yourself to that trigonal pyramidal shape. Okay? So we have a trigonal pyramidal shape. A trigonal pyramidal shape is an uneven arrangement of the molecule. So this is a tetrahedral electron pair shape. If we're naming this, we'd be calling this a tetrahedral electron pair shape. This is a tetrahedral modified electron pair shape. And now that we've gotten rid of all the electron pairs, this is now the molecular shape. And it's a trigonal pyramidal molecular shape. A trigonal pyramidal molecular shape is one of the uneven shapes. A couple of ways to know that. When you have lone pairs that you have to get rid of, you're going to get an uneven arrangement almost every time. The only case that doesn't happen is when you have 3 lone pairs and what remains is just 2 atoms. Sometimes you end up then with an even arrangement, but that's kind of unusual. So most of the time, when we get rid of a pair of electrons or 2 pairs of electrons, we're going to have an uneven arrangement of the atom. Okay. The next thing is we need to know. So we met one of the conditions. One of the conditions is we do have an uneven arrangement. Okay. The second is we want to find out if we're going to have polar bonds. Okay. We want to find if we have polar bonds. So for that, for this class, this level class that I'm teaching here today, you're lucky because you get to use a periodic table with electronegativities. In an honors class, they have to be able to estimate electronegativities. They can't use this table, okay? But I can look and I see nitrogen has an electronegativity of 3.04, and hydrogen has an electronegativity of 2.1 on the Lewis scale. And so I'm going to just subtract. I'm going to take the larger number, 3.04. So this is the electronegativity for nitrogen, okay? I'm going to label that so I know exactly what I'm working with. And then for the electronegativity of hydrogen, that's 2.1. And I want to subtract these two to get to the amount of electronegativity difference. So if I'm subtracting 0 from 4, and remember you cannot put a 0 there because that's going to imply there is precision that's not there. Okay, but if you remember when you did this in math classes, you would have said that's a 0. We're going to subtract 0 from 4, we get a 4. This we're going to subtract from a 9, we're going to take a 1 from over here, so we get 0.94 as our electronegativity difference. So I'm going to write that as END for electronegativity difference, and then in the subscript I'm going to say this is for a bond between nitrogen and hydrogen. Okay, and so that's my electronegativity difference. That is clearly in that polar range. We said that the polar range was between 0.5 and 1.5 electronegativity difference. Okay, so this is clearly in that range. This is between 0.5 and 1.5, so we have met this condition. Since we've met both conditions, then we can make a claim. The claim is this is a polar molecule. Okay, the evidence is that when you determine the shape of the molecule, you can see that it has this trigonal pyramidal shape, and that's an uneven arrangement of bonds. Further, the electronegativity difference for those bonds is 0.94. Okay, justification, claim evidence reasoning. The reasoning then is that a molecule that has an uneven arrangement of bonds and has polar bonds is going to be considered a polar molecule. All right? Claim, evidence, reasoning. Okay? Remember that. CER, C-E-R, claim, evidence, reasoning. All right? So, ammonia is a polar molecule. Okay? All right, let's see. How are we going to figure out how many points to give all this? He says. Okay. So, if I were giving this all the points it deserves, 1, 2 for the symbol and the dot here for hydrogen. So this is 4 and this is 6. 7, 8, 9, 10, 11, 12, 13, 14, 15 points for this part. Okay? Lewis dot formula. Lewis dot formula. I have 8 dots in the right places. Okay? Plus the symbols 9, 10, 11, 12. 12 points for that. Okay? Lewis formula. Well, we don't really need the Lewis formula. So I'm not going to give any points for that because really you can use this to find out the rest of it. Okay? Well, if we were given it points, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? If we were given it points. All right? Now listen. Shh. This shape, I've got a pair of electrons here, 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 here. That's 8. Okay? 9, 10, 11, 12, 13 points. Plus the correct shape, I would give this 14 points probably. Okay? And this is also going to be, well, actually, no. We're going to have 3 less points here. This is 11 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. Okay? This one is 1, 2, 3, 4, 5, 6, 7, 8 points. All right? You have to show that you're subtracting the electronegativities. That's part of your evidence. If you don't have evidence, you don't have a claim. Well, you don't have a reasonable claim. If you don't have evidence, you can't support reasoning. Okay? So let's see, 1, 2, 3. I would just give this 3. Well, we didn't round this off, did we? Should have done that. Okay, so 1, 2, 3, 4, 5, 6 for this. Okay, now then, you have to have claim, evidence, reasoning to support the argument that this is a polar molecule. Claim is it's a polar molecule. That's 2 points. Evidence is you have. Okay, so you have to have evidence, you have to have reasoning, 6 points, 6 points for the subtraction, that's 12 points. I probably should, huh? Somebody, you added up already? You could be wrong. Yeah, I was wrong once. Nobody heard that as a joke. I see, okay.
Did you do that in your head?
All right, so I got a total of 72 points. Okay? I expect you when you do this to show all your work and be clear about your claim, evidence, and reasoning. That make sense? All right? And like I said earlier, we happen to have somebody in here who is in college and who's taking classes with all this stuff in there, and this is helpful, would you say? Oh yeah, there you go. I'm preparing you, hopefully, huh? Does she have a cheat sheet?
Can we use her?
No, you can use her as a resource to learn. You're welcome to ask her questions and stuff, but you can't, use her on tests or quizzes or something. No. All right. I'm not taking this up today. All right. This is your opportunity to see what I expect of you.